In this video, we will look at how a flexible pavement can fail. The flexible pavement road design allows us to construct roads that provide the level of service expected of modern roads at a reasonable price. However, roads can fail by settling or swelling to produce bumpy surfaces on the road surface, or can break up, or the base course and sub-base layers can unravel and break up. There are quite a few things that can go wrong with roads. Some risks, such as overloading by vehicles that are too heavy, are controlled by laws that limit the size of vehicles and loads. However, the road is also exposed to the elements over a long period of time, and that is also a cause of road failure. Water in particular can cause a number of problems if it is able to enter the pavement and subgrade layers in excessive quantities. One problem occurs when there is too much water in the voids between the aggregate particles. The base course and subbase rely on contact between the coarse particles for their strength and are held in place by finer particles. There is usually some water in the voids, but if too much of the void is occupied by water, then it can severely degrade the layer. There are several mechanisms that do this. Firstly, the void water, shown in blue, is pressurized as vehicles pass over the void, and it tends to squirt out. This can dislodge fine particles that are also in the void. Over time, continuous loading and unloading can erode the fine particles out of the voids, resulting in there being less support for coarse particles and so allowing them to move. Secondly, the void water can lubricate the contact surfaces between the coarse particles, increasing the risk of them moving under load. This can happen even if the fine particles are not being eroded out of the layer. Thirdly, the pressurized water also exerts pressure on the coarse particles, forcing them apart, lessening the contact between them, which can also result in them moving under load. So, in summary, excessive water in the subbase and base course layers can result in the loss of strength and eventual failure of the layer. The water needs to be allowed to drain out of these layers, and the base course and subbase aggregates are designed to allow easy and quick drainage. However, the potential issues do not stop when the water runs out of the subbase. It can also weaken and damage the subgrade. If the subgrade is a permeable soil, such as sand or gravel, then it will just keep on flowing down to the water table. In less permeable soils, such as silts and clays, the water flows off the side of the road, as the subgrade surface has the same camber as the road surface. Usually it is taken away by the subsoil drains, and the water content in the subgrade remains at levels that allow it to maintain its design bearing capacity. However, if too much water accumulates in the subgrade, then it can weaken it. This excessive water may come from cracks in the road surfacing, as shown in the top diagram, or it could be a raised water table through flooding or failure of the subsoil drains, or water percolating from drains at the side of the road. Clays and silts soften as the water content increases. Softening results in a reduction in the bearing capacity. You see this when a clay surface gets very wet during rain. The surface gets very soft and muddy. If you walk across it, you sink in and stir it up, making it even more muddy. We design the road so the subgrade has a water content that allows it to maintain the design bearing capacity. However, if the water content does increase too much, then there is a risk that the bearing capacity decreases below the required strength. This results in the subgrade being unable to support the road loadings, and it compresses, as shown in this bottom diagram. The subbase and base course above settle into the deformation, which eventually results in the whole road above deforming, causing hollows and rutting to form the surface shown in the lower diagram. The deformation can also cause drivers to lose control, or at the very least make for an uncomfortable journey. In addition, water will flow to the depression on the road, causing ponding, which is also a traffic hazard. But it also means that even more water flows into the area. If the water is coming from surface cracking, or if the deformation causes cracking, then even more water enters, resulting in even more excessive wetting of the subgrade, more softening, further reduction of the bearing capacity, and even more settling of the road, and so on until failure. So the water needs to be managed properly in the road design and maintenance. The other main source of damage is overloading, as mentioned before, but this is mainly controlled by restricting the size of vehicles allowed on the road.